Hello my friends, I hope you're feeling fantastic now after this first data preprocessing phase that we tackled in a flashlight together. Now we're ready for the exciting step, which is to train the multiple linear regression model on the training set that we now collected thanks to the previous step. But first, before we do this, I would like to answer two important questions. The first question is, do we have to avoid, to do something to avoid the dummy variable trap? And the answer is no, because indeed the multiple linear regression class that we're about to import and which will build the multiple linear regression model itself and actually also train it, because remember that a class actually can complete several actions, including building it and training it, and well, this class will automatically avoid this trap, which means that indeed, one of the three first columns here, because remember Kirill explained that one is redundant, well, will automatically be outcast. So you have nothing to worry about regarding the dummy variable trap. You don't have to remove one of the columns here. And that's the beauty of classes. These are advanced implementations that allow you to build a model, a machine learning model, in just a few lines of code. And this will take care of the dummy variable trap for you. Now, second question, do we have to work on the features to select the best ones with, the techniques that Kirill introduced to you, like, for example, backward elimination? Do we have to deploy the backward elimination technique in order to select the features that have the highest p-values and that are the most statistically significant? And the answer is, once again, no. Why is that? Well, for the exact same reason as the dummy variable trap. The class that we're about to call to build our multiple linear regression model will automatically identify the best features, the features that have the highest p-values or that are the most statistically significant, to figure out how to predict the dependent variable, the profit, with the highest accuracy. So once again, you don't have to worry about this. The class of scikit-learn, this amazing data science library, will take care of everything for you. Okay, so I'm glad I answered these two questions. The purpose of building machine learning models today is to be efficient, because in your career, I can't tell you how many times I had to test several machine learning models on my data set and select the best one. Well, if I had to deploy the backward elimination technique on my data set, well, I would have lost a lot of time. And here we have a class that takes care of everything. You just have to deploy your class on your data set, and then you will get an accuracy, and you will compare that accuracy with the accuracies of other models. And that process is called model selection. That's what we actually cover in the part 10 of this course. So really, I want you to be efficient with your implementations and your machine learning toolkit so that you can optimize your model selection process. Alright, so now that we said this, well, let's build together the multiple linear regression model. And now actually I have some good news, because, we're still doing linear regression. And in the previous section, we actually did simple linear regression, with which we therefore had one feature in our dataset. And now we're doing multiple linear regression, which is exactly the same as simple linear regression, except that we have several features. So the good news is actually that the class that we're about to use to build and train this multiple linear regression model is actually the exact same class as for the simple linear regression model. It will just recognize that there are several features and therefore that we are doing multiple linear regression, but the rest will be exactly the same. It will be trained to understand the correlations between all your features, actually I can open it here, all your features and the profit, which is your dependent variable, and then it will take care of the dummy variable trap, and it will also take care of selecting the best features that are the most statistically significant. So that's the good news, but still, I just want to re-implement this again from scratch to make sure it is best integrated in your head. Alright, so let's close this and let's implement our multiple linear regression model. Actually, try to do it faster than me, try to do it before me, you can press pause on this video and do it. And me, I'm gonna do it pretty efficiently. So remember, we have to start from the sklearn, the scikit-learn library, from which we're gonna get access to this specific module, which is linear model. There we go. Google Colab guesses it perfectly. And from this module, we're going to import, well, the linear regression class. Google Colab guesses again perfectly. Alright, so that's the exact same class as in the previous section on simple linear regression. And there you go, we're going to do just exactly the same. This is exactly the same code as what we did in the previous section, because now we're going to create a new variable which will be our multiple linear regression model, which will be created as an object of this linear regression class. So let's introduce this new variable, regressor, equals, well, since this will be an object of the linear regression class, I'm just copying this class and pasting it here and adding some parentheses. All right, so that regressor is created as an instance of this linear regression class. Now the question is, do we have to enter any parameters here? Well, just like simple linear regression, the answer is no. We are just going to keep the default values of the parameters inside this linear regression class, and there is absolutely no need to understand them. You can check them out in the documentation if you want, but usually when we're building a multiple linear regression model, there is not much parameter to tune. I will explain in a whole section parameter tuning, when you can improve your model, but for linear regression it's pretty simple, so usually we don't have anything to input here. So all good. And now final step, with this line of code we actually built the multiple linear regression model, so we have the model already, only right now it is dumb, it is not trained yet on the dataset, so now we're going to make it smart by training it indeed on our training set composed of, remember, X train and Y train. So there we go, let's take our regressor object, from which we're going to call the fit method, which takes as input, right, exactly the same as before. First, the matrix of features X train, and second, the dependent variable vector Y train of the training set, of course. All right, and that's it. This line of code will build our multiple linear regression model, and this line of code will train it on our training set. All right, perfect. So now let's just execute the cell. So let me check the cells that we didn't execute before. So we executed everything up to here. So we still have to execute this cell, to split indeed the dataset into the training set and test set. And now we have the training set, and therefore we can proceed to this next step to train the multiple linear regression model on the training set. So here we go, let's do it. Clicking play, and there we go. We now have a fully trained linear regression model on this dataset. So now we have a model that was trained to understand the correlations between different types of spends by 50 startups and their profit, so that now investors can deploy this model on new startups in order to predict what profit they will generate based on these informations. All right, perfect. So congratulations. Now let's recap, 3 things. Thanks to this amazing linear regression class, you don't have to worry about the dummy variable trap. You don't either have to worry about selecting the best features, meaning the features with the highest p-value or the most statistically significant. The linear regression class will take care of that as well. And also, you know how to build and train a multiple linear regression model on a dataset, which you also know how to pre-process like a pro. All right, so we're now going to move on to the last step, which will be to predict the test set results, because remember that so far our model was trained on the training set, and therefore we still need to check its performance on new observations, which are contained in the test set. However, here we have to understand something important, compared to what we did in the previous section on simple linear regression. This time we actually have several features, right? We actually have 4 features instead of 1, like before. And therefore we cannot actually plot a graph like we did in simple linear regression, where we have the features in the x-axis and the dependent variable in the y-axis, because simply there are 4 features. We would need actually a 5-dimensional graph, which is not possible to visualize as humans. So what we're going to do instead, instead of visualizing the test set results on a plot, well, we will actually display 2 vectors. The first one is the vectors of the real profit in the test set. And remember that the test set actually counts for 20% of the whole data set, and therefore since here there are, actually 50 observations corresponding to the 50 startups, well, 20% of 50 will be 10 observations in the test set. So we will actually have 10 samples in the test set, and we will display 2 vectors. First, a vector of the 10 real profits from the test set, the 10 ground truth, and a second vector of the 10 predicted profits of the same test set, so that we can compare for each startup of the test set if our predicted profit is close to the real profit. And that's how we will, evaluate our model. And then later on in this part, you will actually learn about some evaluation techniques to measure better the performance of your regression models with some relevant metrics. But so far, this is how we will do it. We will clearly see if, our model performs well on your observations, on the test set, because we will clearly see if the predictions are close to the real result. Okay? So you can try to do it yourself, at least the first step, which is to get the vector of predicted profits. But then in order to display the two vectors, next to each other, well, we'll have to use some certain tricks which are not necessarily obvious. So we'll do that together. All right? So as soon as you're ready, let's proceed to the next tutorial. And until then, enjoy machine learning.